The focus of this lesson is automobile transactions. Example 1. Find the quartiles for the tire pressures of car tires at an auto clinic. They were 15 psi, 17 psi, 21, 25, 31, 32, 32, 32, and 34. Note, tire pressure is measured in psi or pounds per square inch. There are generally manufacturer recommendations for how much pressure should be on your tires, generally around 30 to 34, depending on the tires. So you will note that here the 15 and 17 are really low pressure tires, meaning they came in with not a lot of air. Okay, so what we want to do in order to find the quartiles, because that's what the problem is asking, it's asking us to find the quartiles. Quartile just means quarters or 25%. So we want to take this data set and we want to divide it into fourths. So first thing we need to do is make sure our data is in order from least to greatest. And we can see that it already is, so that makes it easy. The next thing we want to do is we want to find the quartiles, okay? So what we want to do is start by finding the middle. So we're going to cut the data set in half. We'll note here that the middle is actually at 31. And we can see that very clearly because there are 4 numbers to the left and 4 numbers to the right. Okay, and then we're going to recognize that we're going to cut the bottom half or lower half of data in half, and we're going to get another quartile mark. And then we're going to do the same for our top half. Okay, so we're literally cutting it in half and then cutting the bottom half in half and then cutting the top half in half. Okay, so you'll note that we have 4 25%, right? 0 to 25, 25 to 50, 50 to 75, and 75 to 100. Okay, we'll refer to this middle one as Q2. This one over here is Q1. Now you will note with Q1, because that quartile is between the numbers 17 and 21, we're going to cut it in half. So we're going to find the average. We're going to find 17 plus 21, which is 38, and divide that by 2, and we're going to get 19. So Q1 is at 19, and then Q3 is the average of 32 and 32, which is in fact 32. Okay, so we have what's called our first quartile, our second quartile, and our third quartile. And these numbers just mark where the data is cut into quarters. So 1/4 of the data, 1/4 of the data, 1/4 of the data, 1/4 of the data. And then Q4, of course, is our maximum, which is 34. Example 2, find the interquartile range. Mathematically speaking, the interquartile range is defined as the difference between Q1 and Q3. So if we look at the data set from example 1, our interquartile range is going to be the space between Q1 and Q3. So from here to here, in statistics, it's referred to as the IQR, or interquartile range. In this case, our IQR, as I said, is Q3 minus Q1. In this case, that is 32 minus 19. So our interquartile range is 13. Now it's your turn to try. Try this. Find the interquartile range for the data set shown below. Example 3. Find the outliers for these tire prices. $45, $88, $109, $129, $146, $189, $202, $218, and $545. Now note, the boundaries for the outliers are computed using the formulas Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. All right, so the first thing we need to do is we need to identify our quartiles. So let's start there. So let's find our center. So it looks like our median, or our center, is going to be located here at 146. Now, like I said before, the way I can see that is I see that there are 4 numbers to the left of 146 and 4 numbers to the right of 146. So that there is going to be my second quartile, right? My Q2. Now I'm going to look at the lower half of my data. and I'm going to find the center. So I see four numbers on the left, so halfway is going to be right here between that $88 tire and that $109 tire. So I know that my my Q1 is going to be located right here. Okay, so there's my Q1, and then I know my Q3, my third quartile, is going to be between that 202 and 218. All right, now remember what I said before. If you have a quartile that lands between two data points, we're going to find that quartile by finding the average of the two numbers. So I'm going to take the $88 and the 109, and I'm going to divide by 2. All right, so we have 88 plus 109, and we're going to cut that in half. So we see that that's a $98.50. And then for my third quartile, we're going to find the average of 202 and 218. So 202 plus 218, cut it in half, that's a $210 tire. All right, and then of course our Q4 is that 545. Now, in order to determine whether or not you have an outlier in your data set, it has to be either beyond the Q1 minus 1.5 times the interquartile range, or beyond the Q3 plus 1.5 times the interquartile range. So what we're going to do here is we're going to determine what those bounds are. So that minimum and that maximum that is considered allowable within this data set. So let's start with our lower bound, okay? So for our lower bound, that's going to be given by Q1 minus 1.5 times our IQR. Now in this case, our Q1 is $98.50 for the tire, minus 1.5 times our interquartile range. Now remember, the interquartile range, or IQR, is the difference or space between our first and third quartiles. So in this case, that's going to be the space between this 98 50 and this 210, right? So there's our IQR. So our IQR is the difference between 210 and 98.50. So that's 111.50. So 111.50 for our IQR. So when we plug this in, 111.50, we get this formula. So 98.50 minus 1.5 times 11.50. Let's go ahead and calculate that. So 98.50 minus 1.5 times 111.50. We see that our lower bound is actually a negative number, meaning there is no tire price that's going to be an outlier, unless someone's charging us to take the tire away, right? So that's negative 68.75. That's our lower bound. Now we're going to calculate our upper bound very similarly, right? So let's do that over here. So our upper bound for our data set is going to be Q3 plus 1.5 times our IQR. So in this case, that is, our Q3 is 210, so 210 plus 1.5 times our interquartile range, our 111.50, and then let's go ahead and calculate that. So 210 plus 1.5 times our interquartile range, or 111.50, and that is 377.25. So let's write that down right here, 377.25. Okay, so what this is saying is, if the tire price falls between negative $68.75 and positive $377.25, then it is considered reasonable within this data set. It's considered not to be an outlier. So then the question is, are there any outliers in this data set? Now, if you look at all of the numbers in the data set, you will notice that all of the numbers fall within this lower bound and upper bound except one, that maximum number right there. So that 545 up here, we can then say is in fact an outlier. So our 545 tire is an outlier. Better be a fancy tire. Now it's your turn to try. Try this. The store that charged $545 for a tire in example 3 had a sale and lowered the price to $399. Is this new price an upper outlier